example problem. Now, I went ahead and added in my axes so that I can create a vector diagram including all of the information about what's going on here. So a man pushes an 8.1 kilogram mower for 15 meters using a force of 11 newtons at an angle of 65 degrees above the horizontal, or in other words, 65 degrees with the horizontal. Assume that we have a frictionless surface. So I'm going to start by drawing in the displacement, which is going to be to the right as indicated in the diagram. Now, all of the forces acting on the lawnmower. Well, obviously we've got mg, or the force of gravity, going down. We also have a normal force coming up, and we have, I'm going to just move my mg over to the other side, and we have the force of the push coming in at an angle going down and to the right. Or that could be the force of the man, however you want to talk about that. Now, let's go ahead and think about all of our different angles. So for the normal force, the angle between the normal force and the displacement, our angle would be 0 degrees. I'm sorry, not 0, it would be 90 degrees. For the force of gravity, again, we've got a 90-degree angle, and for the force of the push or the force of the man, however you want to refer to it, that is going to be the angle in between the horizontal and the line. And remember, we said that this angle here was 65 degrees, making alternate interior angles congruent. So we've got an angle of 65 degrees to get us started. So we're on a frictionless surface, so we don't have to worry about friction. So let's start with the what is the net work on the mower. So the work net is going to be equal to the sum of the works, or the work done by each of the different forces. So we've got the work done by the normal force, plus the work done by gravity, plus the work done by the push. Now, before, if you remember, we figured out that if the angle is 90, then the work done by that force is going to be 0 joules, because if the force is perpendicular to the displacement, it can do no work, meaning that the work net is simply going to be the force of the push times d times the cosine of the angle between the push and the displacement, which gives us that the work net is going to be 11 newtons times the 15 meters times the cosine of the angle of 65 degrees. Oops, degree sign goes in there, which is going to give us a value with a little punchy of 69.732013, on and on and on, or that the net work is going to equal 69.7 joules. All right. So now, according to the work energy theorem, what is going to be the final velocity of the mower? So using the work kinetic energy theorem, that the net work is equal to the change in kinetic energy, which would mean 1/2 mv final squared minus